Good morning, and for everybody, let me share my research about effect of salinity on agronomic characteristic of tree rice variety at tillering stage. Presented by me have information about MC about my name, Felisberto Soares. Is complete. My name is mostly pronounced by Portuguese language. So I am a student of Master Bioscience at Silpakorn University, Faculty Animal Science and Agricultural Technology, Silpakorn University, IT Campus, Phetchaburi, Thailand. To be my outline today is about introduction, objectives, phase of study, research methodology, results, and discussion and conclusion. To be my introduction today is about rice as staple food that is widely consumed by people in developing countries. One of environmental challenges affecting production is climate change. Climate change will aggravate a variety of stresses, namely heat, drought, salinity, and submergence. In rice production under salinity stress, salinity is one of the major impediments to increasing production in rice growing areas worldwide, being secondary only to drought. Level of salinity affecting the important agronomic characteristics in vegetative stage, which is the period of tiller establishment. For this reason, study to determine the level of salinity affecting important agronomic characteristics in vegetative stage, which is in the period of tiller establishment required. The aim of this research is to identify the effect of salinity from sodium chloride affecting some agronomic characteristics of some rice variety at tillering stage. In research methodology, an plant material consists of 3 rice varieties. There are for variety China 1, Patuntani 1, and Impari 55. In salinity level consists of 0, 50, 100, and 150 millimolar. In cultural practice consists of rice seed soaking 24 hours, sown into the soil, depth 2 to 3 centimeters at the nursery for 2 weeks, seedling, transplanting in the polybag, 3 plants per polybag. Rice plant were started receiving salinity water after 2 weeks of transplanting. Soil physical and chemical properties. Some physical and chemical properties of soil sampling were measured before the study began. And also electrical conductivity was evaluated again after applied water salinity followed by its treatment. Characteristics were recorded consist of leaf number, tiller number, height of plant, and scores symptoms. The experimental design arranged as 4 times 3 factorial in completely randomized design. 4 level salinity, 3 variety rice, 12 treatment, 5 replication, and 3 plant per pot. Data was analyzed by using ANOVA for statistical significant difference between treatment, then compare treatment by using DMRT. All statistical analysis was performed using APOGA. Site experiment, the study was conducted at the Faculty of Animal Science and Faculty of Technology, Information and Technology Campus, Silpakorn University, Phetchaburi Province, Thailand, 2020. Result in table 1, effect of the different salinity level on 4 agronomic characteristics of 3 rice variety at week 1 after adding salinity. There are significantly different effects of 3 rice variety. For salinity levels are not significantly different effect on 3 agronomic characteristics except in leaf symptoms. In table 2, at week 3 after adding salinity, there are significantly different effects on 4 agronomic characteristics of the rice varieties. In salinity level, different significantly effect on 4 agronomic characteristics. Many characteristics of Thai rice variety were affected by salinity. Reduction percentage in number leaf per plant height, and positive percentage leaf symptom scoring. However, only 35 had increased number leaf per plant, number tilled per plant when increasing salinity stress. The influence of leaf formation, plant height, number tiller, and other agronomic properties occur at the vegetative and reproductive stage. Some plants can also demonstrate stunted growth, chlorosis, intervenium, chlorosis, and necrosis during salt stress. The response of rice to salinity stress depends on genetic factors. PT1 had higher leaf symptom score, while Impari 35 and CT1 had lower scores. Impari 35 showed that the values of leaf per plant, tiller per plant, and plant height were higher than those of 2 Thai rice varieties. There are CT1 and PT1. The lowest number tiller per plant and the highest leaf symptom score were shown in PT1. Therefore, it is possible that PT1 is more susceptible to salinity stress than CT1 and Impari 35. The number tiller per plant in rice is very important for yield. It is affected by both genetic environment. The varieties with high adaptability can produce better growth and more ability to physiologically and morphological than other varieties under specific stress condition. In this study, these 3 varieties show different corresponding salt tolerance at tillering stage. For my research, at the end, I want to conclude about salinity had a very significant effect on number leaf per plant, number tiller per plant, and plant height, and score of leaf symptom on leaf in rice variety. The effect of salinity stress was observed on leaf symptoms since the first week after adding salinity. And other characteristic was significant, determined at week 3 after adding salinity. For rice variety, there is significant difference since at first week after adding salinity. Overall mean of observed agronomic characteristic on Impari 35 generally show higher values than PT1 and CT1 in week 1 and week 3. Impari 35 also show lower reduction percentage compared to 2 Thai rice, CT1 and PT1 at week 3 after transplanting in number of tiller per plant. In assessment, the author would like to thank Faculty of Animal Science and Agricultural Technology, Silpakorn University, Thailand International Cooperation Agency for financial support to complete this research. Thank you for your attention. Welcome for there are any questions. Thank you so much.
Okay, thank you very much, Mr. Felisberto Soares.
Yes.
Okay, is there any questions from the audience? Okay, please go ahead. Any questions? Oh, okay. So I think a very interesting presentation and work. I just wonder, in Thailand, do you know which part of Thailand that have a problem from the salinity to grow rice? Which part of Thailand you think, or you know it?
Honestly, I didn't know where is the part of Thailand that's affecting, what area that's affected by salinity. But I am new, I am a student, so I just, this is my research. That's why I conducted in Pechaburi, especially at the Sipakon campus. This is my first time how to conduct this and to know how they affected salinity to rice, tea rice variety. Which variety is very resistant to the rice, to salinity.
Okay, so I just wonder, is the rice, the Indonesia variant, is it, how about the taste? You think it's good or not for consumption?
This is in my case just only until the tillering stage. But I think in the first presentation about my friend Luzongju, he already saw about the result of this. But for the vegetative stage about tillering stage, it's good enough for the Impar 35. It's registered. It's shown the good result then to Thai rice.
So you think if any region of Thailand that have the problem from the salinity, they should replace to grow, I mean, with the Indonesian variant or not? Or is there, if there is a problem, is there any other way to solve the problem with some kind of chemical or something?
Yes, for further research, I think for another part of Thailand, especially for the area where close to the sea, that should be choose any chemical to help, even though that plant that's seriously affected by salinity, they can choose some chemical like proline or trehalose can help the plant, and then as a exogenous application to help a plant for recovery of salinity stress.
Okay, well, very well. Thank you so much for your nice presentation. Okay, thank you.